Hey, what's going on, folks? It's Mike here, and welcome back to the D Programming Language series. In today's lesson, we're going to be looking at a new keyword known as the version keyword. And this has something to do with how we preprocess or do conditional compilation in the D programming language. So in order to best show this, I want to go ahead and compare it to the way that you do things in C, and then show you the way that you do things in the D programming language. So let's go ahead and dive into our favorite website here, the D programming language website, dlang.org. And I'm actually going to start us off from the article section. So you can get there from the homepage, documentation, and articles, which I'm already here. And if you scroll down, there's a nice article on the C preprocessor versus D that will introduce this feature of the version keyword. So again, as noted from this article, D doesn't have a preprocessor. So this is going to show how you do things in the D way. Now, if you haven't used the C programming language, this doesn't much matter here, but I want to go ahead and try to just motivate this feature and what exactly it's for as we talk about it. So I'm going to go ahead and click on this article, and I'm going to go ahead and take us down to this conditional compilation number 5 here on the contents here. I'm just going to scroll up a little bit because it's actually part of this next section, and then we'll get into the conditional compilation. But when we're talking about how to do things in the C preprocessor, for example, let's say you've got a bunch of different platforms or different features that you want to support. Well, the way that you had to do this in the past, because compilers were, well, when they were built in the 1970s, like when C was around, we had to have some like clever tricks and ways that we did things. So what we did was we created this sort of preprocessor and macro language and so on to basically conditionally compile. So anything in the C language, for instance, with a pound symbol in front of it, and then some symbol or identifier here. And basically, if this symbol was defined, then we go ahead and include this code here, and we can include other defines that do other things here. Well, the reality is that we sort of end up building our own little language or vocabulary here, so things get a little bit messy. So the D's way of doing this is just to have a version keyword here, and you could sort of use this in the same way where you have else and else if statements and so on here for your versions of software. So with that said, that's going to be the feature that we're most interested in here. We have some identifier here that if it's enabled, that means execute this block of code. Otherwise, we will execute and compile in this block of code. Or rather, I shouldn't say execute, but I should say we put in this block of code to potentially be executed in the actual run of our program. So it's one or the other, depending on this version here. And you can see that this is being used for something like Unicode. So if you're supporting multiple languages, for instance, there might be different changes you need to make with the data types or what functions you call and so on. So this is one example of a type of abstraction that you could use. I think the most common one, though, that we're going to be interested in is if we are supporting multiple platforms. And I'll show you an example at the end as we learn to use this feature. So let's go ahead to the D language here in the language reference. And I'm going to go ahead and scroll down here a little bit to conditional compilation. And let's just go ahead and give that a click here. And we have a version specifier, which is the first thing here. So let's just go ahead and move this over to the side here. Let's get our windows set up here appropriately and look at the version condition here. Now, again, it's just a simple keyword here that has if some condition is satisfied, then we will bring in that block of code here. Okay, so that's the idea here. Now, we are going to talk about unit tests pretty soon, and there's a special version unit test for that. There's also a version assert here. We're going to be talking about this version identifier here today. So let's go ahead and see how we use this feature. And the reason that I'm talking about this particular feature today is if you watch the previous lesson on static assert, which was something that happened at compile time, this is another sort of thing that happens, well, at compile time. And we also have a way that we can use asserts and static asserts with this version feature, or how I like to use it otherwise. So anyways, here's how we basically use the feature here. Let's just look at a little demo here. And if this demo identifier is available, then that means we compile in this code block for the demo version. So again, you might have a demo version, a basic version, a professional version, a shareware version, a trial version of your software, whatever the identifiers might be that specify different blocks of code here. So again, very important if you're distributing your software, whether for commercial purposes or so on, that you could use this feature here. So let's just go ahead and play around with it here. And let's go ahead and do version demo. And I'm just going to do a write line here and say this is the demo version. And let's go ahead and just compile this code here. And I'll use RDMD here. And of course, you're not going to see anything here because this isn't the version software here, okay? Or the demo. This constraint here, version for demo, is not identified anywhere. At least I don't know what this means here, okay? So how do we sort of turn this on or turn on this block of code? Well, for that, I'm going to go ahead to the command line reference. And again, just to show you how to get here, from documentation, command line reference, and I'm going to be at the Linux version here because that's the platform I'm on. And we're just going to search for version or the dash version flag here. So this is what we care about here. So we want to compile in a version identifier or specify one. Okay, so let's go ahead and do that here. And I can do this with rdmd. And I'm just going to do bash version equals demo. And now when I run it, we see this is the demo version here. Okay, so simple as that here. Now, we want to be a little bit careful with how we use this. So if I put in an else block here, and let's put this is the professional version. Let's go ahead and compile this again. And again, we see this is the demo version. And if we just did our regular compile, so demo is not found, then we will see that this is the professional version. Okay, so you want to be, these are types of things that you might want to build into your or validate somehow in your build system or continuous integration and so on to make sure that if you are distributing a demo version versus like the professional version of a software, you have some way to catch these things. So that's a little bit more just on like software construction and distribution and so on. But let's keep diving into this a little bit more in the specification here. What else can we do with version here? Well, we can actually do this kind of interesting operation here. I'll talk about the platforms in a moment here, but you can actually do version equals feature A, version equals feature B, and so on. So that's another way that you could kind of use this here. So let's say if I want to specify, maybe within my build for some reason here, version equals demo, and let's just do a regular rdmd and compile. It says, okay, first problem here is it must be at the module level here. Okay, so that means I can't put it within this block. I got to move it up somewhere here. Okay, I believe it does say that somewhere here. Yeah, version specifications may only appear at the module scope. Okay, so let's go ahead and move things up. And that sort of makes sense because as the compiler is parsing your code, you want this at a higher level for the module. So I can actually specify these per module, which is kind of neat here. Okay, so now I can run it here. And that's another way to set things up here. Now, whether or not you want to pass this in as a compiler flag, specify in the code, or maybe use some of the other features that we've talked about in this series, like mix-ins and importing a mix-in of code and so on, those will be things for you to decide. But don't forget about those features, because again, we could do a string mix-in here. And again, let's just put in regular decode. You could do something like that. You could do a import, and let's just call it config.txt here. And let's go ahead and comment this out. Let's create a little config.txt here. And we'll just say version equals demo. Okay. And if you remember how to use this feature, we use mixin, the import statement, and then we have to use -j main.d and the directory, because that will tell us it's legal to import things within the current directory here and search for them. That's another way that you could sort of set up a configuration to bring in all of your versions and so on. Again, so just a few different ideas here for how to use this feature. Okay, and then as mentioned in this sample here, if you have a professional version, then you could enable feature by feature different things here. So again, a nice way to sort of control what's going on once you have like the base level or high level functionality defined. Okay, so this makes it very easy to do. Okay, now the last thing that I really want to talk about here, and where I mostly use this feature, is demonstrated right here. Okay, so you have some platform specific detail, like maybe it's your architecture being x86 or ARM or something of that nature. That would be important. So let's go ahead and scroll down here. And let's actually make this bigger just for a moment here. You'll notice there's a bunch of these predefined versions available. So these are things that we can automatically sort of detect here. So several environmental version identifiers and identifier namespaces are predefined for consistent usage. Version identifiers do not conflict with other identifiers in the code. They are in a separate namespace. And predefined version identifiers are global. They apply to all modules being compiled and imported. Okay, so really important to keep in mind. So for example, let's just go ahead and do another version here. Let's just say I'm on Linux, and that's one of the predefined specifiers. And we do want to make sure these are, case sensitive. Notice the Mac one is OS X here, all capitals, but let's go ahead and write out, we are on Linux platform. Let's just make sure. And let's go ahead and run this here. Now this is going to fail because I have my mix in here. So let's just comment that out for now. And let's just go ahead and run so we can focus on this Linux piece here. And let's go say, yes, we are on the Linux platform. Okay, so now if I have my, version OS X, let's go ahead and say, right, we are on Mac, something like this. And you can do RDMD. And you can see clearly we're not on the Mac platform, okay? OS X, so we're not, okay? We are on Linux. Now, you kind of want to be careful with these here. And let's see how we could kind of group these together here. Again, you can have else statements here. Let's go ahead and group these and see if we could do something like a else if statement. So let's say else if, so I can put these together. Okay, now let's see. Okay, so this is saying found version. Okay, so let's go ahead and kind of group it like this here. There we go. So now we can use else if OS X. And let's say that we're not supporting, Linux and Mac are kind of similar environments. Not exactly, but let's say that we're not able to support either of those. And let's just go ahead and write out, or maybe let's actually do this here since we know we're on Linux. Let's go ahead and find the Windows. Let's do Win64 here. Or you could just do any Windows system. Windows. And let's go ahead and say Windows platform. And let's just go ahead and say we are not on Windows or Mac. Okay, so again, just playing around with this. Oops, let's see, I made a little mistake here. Or did I? And this is kind of where things are kind of funky here because what we really want is if this block fails here, this version, we do want to do like sort of an else version here. And this is sort of like an else if here, okay? So again, it's maybe a little bit weird. Maybe it should be else if, I don't know, but it's kind of just following through here and saying if it's not this version, then we're on the Windows platform. Here we're on the Mac, and then we must be neither on Windows or Mac if these aren't passing here, okay? So again, a little bit of a strange thing. I'm trying to see, let's see if there's another example here in the docs. Now we're getting into other stuff here, but with our x86 example, let's see. I think that's the only one. The way I would recommend using versions versus the else conditions is to just sort of keep them at 2 levels like here, since it is giving this like sort of interesting fall through behavior here. That's probably what I'd recommend just with the syntax here. I'm trying to see if there's something in the grammar explicitly telling us, right? Because there's basically else and no else if here, okay? So this is a little bit weird. I would be, a little bit careful with these. And the way that I do this, and I'll show you a real piece of code here, is literally just have the explicit versions here. Version, Linux here. I would just kind of write it out like this. You can use the else statements and so on. But I don't know, this was just a little bit more clear to me. Okay, so if I go ahead and run this, you'll get the same result here with the version. Now, the last little trick I will show you is, let's say none of these versions are supported. One thing that you can do, for instance, is you could just do an else, and then, well, let's do something like a, well, let me think about this here, actually. Let's just do, actually the else version works well, because we do want this, for this particular case, to fall through. But what I want to do here is have a static assert that just asserts no platforms are supported. Okay. And basically what this is going to do here is if we don't have one of these platforms listed that's supported, then it will hit or trigger this assertion here. Okay, because we want our program to fail here. Okay, now in order for this to fail, I need to do something like put in some other platform here. Let's put in, I think PlayStation 4 is one. Let's see if its syntax highlights though. Yeah, PlayStation 4. Okay, it might not highlight here. But we do get this static assert here. And let's go ahead and, just because I'm pretty sure none of you are writing on PlayStation following this series here, we will get our static assert here. And this is really nice if you're building, say, libraries of code that might have different implementations. So, for example, if you're doing threads or something, or loading shared libraries from some like C API, and you're using that in your D code, right? Windows might be different versus Linux or PlayStation or whatever. So that's sort of the feature idea there. Okay, so that's the idea with this version feature here, and a little trick that I like to use here. Now, some other things here. I just wanted to show you a piece of code. This is from the bind BC library. And I think this is how the author, Mike Parker, I believe, and who originally set up some of these libraries. I think it's maintained by somebody else even now, or they're collaborating. But either way, from their samples, that's kind of where I learned this trick here of checking the versions here for OS X for loading libraries, Linux, a different way to load and support libraries. And then I've got the Windows one here as well to compile in and load different code, because Windows has dynamic link libraries, again, which are a different thing. So for instance, so that's just again, a real world sort of example of this code, and how I've kind of worked with it in one pragmatic way, as well as in sort of library code. But with that said, that's the version feature. And it improves on the C way of doing things. So if we go back to that original article here, again, the C way of doing things, let's see, with the preprocessor, we can update that with version. And I think it's just more clear what the feature is, for how things work. And we don't really need a preprocessor in the D language, because, again, we could compile and execute our code using compile time function execution. Okay, so there's a little summary here, and again, the idea being that if we have these sort of, instead of having these if blocks that are used in languages like C and C++, we just use the version specifier. Alrighty, folks, so hopefully you enjoyed this lesson. Hopefully you learned something about version. And maybe this will even give you some ideas if you are writing a lot of like C code or something on how to clear things up here. I like, that sort of strategy. And as always, you can find all my videos and other courses on the courses.mshio.playlist, so you can track your progress in a more distraction-free environment. And yeah, let me know if you have other use cases for version, or if you've got it to do something else interesting beyond those different use cases. I'd be curious to hear about that. Anyways, folks, thanks as always for your time and attention, and I'll look forward to working with you in the next video here.